Chapter 2, Section 6, More on Inequalities and Problem Solving. So in this section, what we're going to do is we're going to continue solving inequalities. We're going to solve them and graph them. So the first thing that we're going to talk about is how to solve inequalities with fractions. And in order to do that, we're going to clear the fractions first, just like what we did when we were solving equations. So remember, to clear fractions, what you're going to do is you're going to find the least common denominator between all terms. So here we have 1, 2, 3 terms, and the least common denominator between 2, 4, and 8 is 8. And so if you'll remember, we're going to multiply every term by 8. So half of 8 times 1/2 is going to be 4, so that's going to give us 4m. And then if we do 8 times 3/4, 8 times 3/4, basically 8 will go into 4, or 4 going to 8 2 times, and 2 times 3 is 6, so we'll get 6m less than, and 8 times 3/8 is simply going to be 3. From here, we just do our normal solving techniques. Combine like terms. 4m and 6m is going to be 10m less than 3. To get m by itself, I need to divide by 10. And I'm going to have m is less than 3/10. So, to put this on a number line, basically we're going to have the two numbers that 3/10 is in between is going to be 0 and 1, and we're just going to guesstimate it to be about right here. So we need all numbers less than 3/10, so it's going to be a parenthesis, and we're going to color to the left. Now for interval notation, you're going to have open parenthesis and infinity, because remember the arrows mean infinity, all the way to 3/10, and we cannot include 3/10, so it gets a parenthesis as well. So the one on the right, the least common multiple, or least common denominator between 3, 4, and 12 is going to be 12. Alright, so we'll multiply everything through by 12. So 3 will go into 12 4 times, so we're going to multiply 4 times that numerator. 4 will go into 12 3 times, and remember this minus sign is going to go here, so we'll have negative 3 times 3x plus 1 is less than or equal to 12 will go into itself 1 time, and of course 1 times 5 is 5. So from here we're just going to solve, so we'll do the distributive property, and we'll have 8x minus 4 minus 9x minus 3 less than or equal to 5. Combining like terms, combine our x's together, we'll get negative 1x, and combine negative 4 and negative 3, and we'll get negative 7 less than or equal to 5. Continue to solve, so we'll add 7 to both sides, and we'll have negative x is less than or equal to 12. Now I have a negative 1, so I need to divide by negative 1, and when I do that, I need to turn that inequality around. And so we're going to have x is greater than or equal to negative 12. So again, to put it on a graph, negative 12 is the number in question. X can be equal to, so we're going to put a bracket, and it's going to be greater than, so it's going to go to the right, and color it in. And in interval notation, we're going to have a bracket at negative 12 all the way to positive infinity. And then back over here on the left, this is actually negative infinity, so that's negative infinity, so let's fix that. The one to the right is positive infinity. Alright, so let's try an applied problem. It says Tom has scores of 50, 97, 72, and 84 on his first 4 math exams. What score must he make on the 5th exam to have an average of 75.2 or better for the 5 exams? Well, if you remember your average formula, we talked about this earlier, average is going to be however many elements you're talking about. In this case, we're talking about 5, divided by the number of elements. So he wants an average of a minimum of 75.2 or equal to. And so let's do his average. So we'll add up the scores that he already has. 50 plus 97 plus 72 plus 84 plus the 5th exam divided by 5. So the first thing I want to do is I want to multiply both sides by that denominator of 5 just to get rid of that fraction. And so when we do that, on the right hand side, these two cancel out. Don't do any kind of distributing or anything like that. They just cancel out. So on the left hand side, we'll do 5 times 75.2. And so we'll have 376 is less than or equal to, let's add up the other test scores. And we'll get 303 plus x. So, to get x by itself, we're just going to minus 303 from both sides. And you can see that when you do that, you're going to get a 73. So basically this says that Tom has to make a 73 or less, or better, I'm sorry, a 73 or better in order to pull out a 75.2 or higher. Alright, what about compound inequalities? Compound inequalities just basically mean that we have two inequalities in the same problem. So when the word and is used, or no word is used at all, this is called a conjunction. So you'll hear me say the word conjunction a lot. When you hear me say the word conjunction, either one, you should see the word and, or you won't see anything at all, but you will see two inequalities. So for a conjunction, it could look like this, or it could actually use the word and. So this means that all parts of the compound statement must be true. So what we're going to do is we're going to solve these compound inequalities, graph them, and write them in interval notation. So if it's set up like this, it's fairly simple. All you have to do is solve each problem separately. So we would minus 1 from both sides, and we'd have 3x greater than negative 6 and divide both sides by 3, and so we'll have x is greater than negative 2. The one on the right, if we minus 5 from both sides, we'll have negative 2x is greater than 2, and if we divide by negative 2, we'll have x is less than negative 1. So there's our solutions. Now, when you have a conjunction, when you graph a conjunction, the graph each solution on the same number line, and these solutions should overlap. So let's see what happens. Since this is a conjunction, that means your graph should converge, which means it comes together. So let's put negative 2 and negative 1 on the number line. So the one on the left says that x can be any number greater than negative 2, so we'll put a parenthesis going to the right, greater than. But the one on the right says that x has to be less than negative 1, so we'll put a parenthesis going to the left, less than, and start coloring. And you can see that these two graphs overlap, and I know I did it right because I do have a conjunction graph. Now for interval notation, it's really simple because you're just recopying the graph. So for interval notation, you're going to have a parenthesis, negative 2, comma, negative 1, close parenthesis. So there's your solution for this compound inequality. Now, if we have this one where, like I said, you don't see the word and, you have options, and I'm going to show you both options. Either one, you can break it up and write the word and it would look like this. You'd have negative 17 less than or equal to 3x minus 2, and 3x minus 2 less than or equal to 10. So you notice the part in the middle has to be used twice with the word and. And then you can solve it down like we did in the previous problem. Or if you don't want to break it apart, you can solve this just the way that it's set up. Just like a normal equation or inequality, we're going to try to get x by itself. So to get x by itself, we need to get rid of this negative 2. So you know that you would have to add 2. Well, when you do that, you have to add 2 on this side of the inequality, and you have to add 2 on this side of the inequality. So now these cancel out, and then you have negative 17 and 2, which is going to be negative 15, less than or equal to, the 3x is still there, less than or equal to 12. And then the last step to get x by itself is we would divide everything by 3. So we'll have negative 5 less than or equal to x less than or equal to 4. So let's get this on a graph. So we have a negative 5 and a 4. So notice that x is in between negative 5 and 4. That's how I know it's a conjunction. This time x can be equal to 5, so we're going to do a bracket, but x needs to be greater than. So we'll start coloring greater than. The one on the right, it says that x can be equal to 4, but it's going to be less than, so we'll go to the left, and we know we did it right. So the interval notation is going to be from negative 5 to 4, not including. Or it is including. So that's why we have our brackets. So x can be negative 5 and can be negative 4 and everything in between. So the next one that we're going to talk about is a disjunction. We just talked about the conjunction, and with the conjunction you're going to see the word and the graph should converge. With a disjunction you will see the word or. You don't have a choice. You have to see the word or. If you see the word or, it is a disjunction and your graphs are going to diverge. In other words, they're going to go away. So this means that any part of the compound statement can be true. To solve a disjunction, what you're going to do is just like what we did previously, you're going to solve each inequality separately. So let's look at this example. You see the word or, so I know it is a disjunction. So let's solve the problem on the left. So we'll add 5. And we'll have 2x less than negative 6. And then we'll divide by 2. And so we'll have x less than negative 3. On the right hand side, we'll minus 1. And so we'll have 5x greater than or equal to 5. Divide by 5. And so we have x is greater than or equal to 1. Alright, so let's try to put this on a graph. Notice it says to graph a disjunction, graph each solution on the same number line. Notice in red, solutions should go in opposite directions. That means they should diverge. So we have a negative 3 in question, and we have a 1 in question. The one on the left says that x has to be less than negative 3, cannot include, so it will be a parenthesis. And we're going to color to the left because it's less than. The one on the right says that x is going to be greater than or equal to 1. So this is going to be a bracket, and it's going to be greater than. Now, for interval notation, this is a little bit tricky. For interval notation, you're going to copy what you see on this number line. And you know that this arrow means negative infinity, and this arrow means positive infinity. So when you write interval notations, it's very important. When you write interval notations from the graph, you're going to copy it from left to right. So on the left side of this graph, I start with a negative infinity. And it's not including, you can never include infinity, so it's going to be a parenthesis, negative infinity, and we're going to go all the way to negative 3, and it's also a parenthesis because x cannot be negative 3. Now, what about this area in the middle? The graph skips this area in the middle, but we need to unite them when we pick back up at 1. So we use what we call a union symbol, which is just a U. It's called union or cup. And then we pick back up at the 1. It can be equal to 1, so we're going to use a bracket. 1 all the way to positive infinity, and you cannot include positive infinity, so that is going to be a parenthesis. So that's the way you're going to see these answers written. Alright, so let's try one more. Here we have a disjunction. I know that because I see the word or. So let's solve the one on the left. We'll minus 1 from both sides. And so we'll have 3x is less than negative 2. Divide both sides by 3. And we have x is less than negative 2/3. The one on the right, we'll minus 2 from both sides. And so we'll have 3x is greater than negative 1. And so we'll divide by 3. And so we have x is greater than negative 1/3. So let's put this on a number line. And our two numbers are going to fall in between 0 and negative 1. So negative 2/3 is going to be closer to negative 1. And negative 1/3 is going to be closer to 0. So the one on the left says that x has to be less than negative 2/3. Less than negative 2/3. So we'll put a parenthesis and color all the way to negative infinity. The one on the right says x has to be greater than negative 1/3. So we'll put a parenthesis and color to the right all the way to positive infinity. So my graph diverges, so we know we got it right. And then for our interval notation, remember you read your graph from left to right. So we're going to open up a parenthesis from negative infinity, and we're going to go all the way to negative 2/3 and close it up with a parenthesis because x cannot be equal either one of those. And then we're going to unite our graphs again with a parenthesis at negative 1/3 and go all the way to infinity with another parenthesis, and again because x cannot be equal to those. Alright, so there are your inequalities. I would appreciate it if you would go ahead and work these problems. If you need help, look back in this video or check out the book.